For the ones who just joined, it's Bonzet here. We've already been busy for an hour. We're going into our second hour to get you guys prepared for that final examination tomorrow. Liberty, thank you so much for this opportunity. Guys at home, give the Tenfold Education app a follow. It's definitely going to help you with your studies moving forward. Okay, so just before the ad break, we looked at occlusions. So we discussed mid-latitude cyclones, anticyclones. Now we're going to look at mid-latitude cyclones when we experience the occlusion stage. It's when the cold front is eventually caught up with the warm front. Okay, and this is basically what happens. So this is when the cold front, this is the cold front over there, and the warm front, they caught up with one another. And the whole system moves west to east, and because in the clockwise circulation. Now, very simple, when they're going to ask you the occlusion stage, right? Think of we get two different types of occlusion. A warm front occlusion, okay, and we have a cold front occlusion. Now, great Charles, the easiest way to explain this to you, if you struggle to explain it, do yourself a favor, you are allowed to draw the image immediately. Okay, draw the image if you need to explain it. What happens with a warm front occlusion, it's when the cold front and warm front eventually caught up with one another. The warm front attaches itself to the surface. Okay, very important. It's the warm front that attaches itself to the surface right there. And the cold front is attached to the warm front. The simple reason why is because we find the coldest air closest to the surface. The air in front of the warm front is very cold. The air behind the cold front is not as cold, and all the warm air has been displaced upwards. Okay, now I understand if you look at this diagram, I can just quickly tell you, if you need to explain to me, if someone asks you, if they ask you in a question paper, what is a warm front occlusion? And it's so difficult to actually point out and just use a diagram. It's for instance, it's when the air in front of the warm front is much colder than the air behind the cold front, and the warm front attaches itself to the surface. Okay, that's a mouthful, okay, of fronts and cold and warm, etc. Okay, so use the diagram to give you a clear image, you know, and to be able to interpret it much better. Okay, when we look at the cold front occlusion, first of all, once again, the cold front caught up with the warm front. The cold front will attach itself to the surface as such. The warm front will attach itself to the cold front. Simple reason why is because the air behind the cold front is extremely cold, very cold. The air in front of the warm front is only cold. It's not as cold as the air behind the cold front, and all the warm air has been displaced. Okay. We rarely see the occlusion stage in Southern Africa. We only experience the cold front. Okay, just to wrap up mid-latitude cyclones. Okay, just to wrap it up. Always think social, environmental, and economical consequences. Yes, going back to our first diagram, just to show you. This mid-latitude cyclones that's been represented here on the synoptic chart, as you can see, it's only the cold front that influences us. Now, yes, it has an impact on South Africa. Okay, quite an important impact. First of all, it provides us with Mediterranean rainfall. Okay, Mediterranean rainfall is winter rainfall that we experience in the Western Cape. Okay, if you look at the Western Cape, when do they receive their rainfall? During winter. Okay, why? Because of the mid-latitude cyclone, because of this cold front that we experience over here. Now, it's not all bad. Yes, it's a mid-latitude cyclone, not even close as vicious as a tropical cyclone. That's going to be my next topic. Okay, it provides much needed rain. It provides much needed irrigation for the farmers. Now with that rain, our wine industry, our grape industry, our citrus industry, fruit industry, it's booming, okay? The majority of the fruit that we farm in South Africa, we export it to European countries. So what does it do? It increases our GDP, okay? It brings in foreign income. It provides job opportunities. Remember, if it wasn't for these mid-latitude cyclones, the Western Cape won't have such many activities taking place. That rainfall is a necessity, okay? Socially, it means unemployment is low. It means the government is earning tax. We can build more schools. We can build more hospitals. Environmentally, it's good for fertilizing the soil, okay? So mid-latitude cyclones is not always our enemy, okay? I actually think it's more of a friend than a foe, okay? But negative consequences, we might experience flooding. Flooding might destroy the crops. It might lead to unemployment, job losses, okay? It means we need to import instead of export. Socially, loss of life. You might lose your homes. Environmentally, might cause soil erosion, okay? Might cause deforestation. So there's a positive and a negative when it comes to mid-latitude cyclones, okay? Remember to think economically, socially, environmentally, okay? That's mid-latitude cyclones. Mid-latitude cyclones between 45 degrees and 60 degrees. It's got a cold front, warm front, west to east in the westerly wind belt, okay? Cold front catches up with the warm front, okay? Experience frontal rain. When the cold front catches up with the warm front, occluded stage. Okay, now we're getting to tropical cyclones. Many of you asked the difference between the two, and I'm going to explain it to you. Okay, so when we look at tropical cyclones, just want to get to the image that I want to use. We have a case study. Now, first of all, a tropical cyclone. By now, all of us know what's a cyclone. It's a low-pressure system. Okay. This low-pressure system develops because of warm conditions. And immediately, why do I say warm? Because tropical. If you think tropical grade 12, what do you think? You think cocktails, you think beaches, you think everything. Okay. You think warm conditions, beautiful beach conditions, tropical, humid climates. And where do we find these tropical regions? Close to the equator, am I correct? So if we look at tropical cyclones, the formation, I'm going to make notes over here. Okay, it's a low pressure system. It's a clockwise circulation of air in the southern hemisphere. Now, it's tropical because it develops between 5 degrees, 25 degrees north and south of the equator. Okay, now first of all, very importantly, it can't develop between 0 and 5 degrees at the equator. Okay, so just to put it in perspective, if you look at your latitude belt, I'm going to wipe this off again. There's the equator. There's the 30 degree. There's a 60 degree. And there's 90. Okay, it can't develop 5 degrees from the equator. Why not? Can't develop over there. There's not enough Coriolis force. Okay. Now, what do we know? This is just going to make it so much simpler to explain. There's a low pressure belt because of extremely hot conditions. This is where we are. high pressure belt, low pressure belt, high pressure belt. Air moves from a high pressure to a low pressure, but because of Coriolis force, what happens? It gets deflected. So what do we have? Our tropical easterlies. Air moves from a high pressure to a low pressure. It gets deflected because of Coriolis force, and we have our westerlies. Now remember, when you move to the equator, temperature increase. When you move away from the equator, temperature decrease. Okay. Now, I've mentioned, so it's in tropical regions between 5 and 25 degrees Celsius. Not Celsius, latitude, man. Okay. So, it develops from there to there. Now, obviously, the initial stage where it develops, so it moves in a easterly direction. Okay. But eventually it will recurve because what do we have over here? The westerlies. So the mature stage is somewhere around here, 25 degrees and 30 degrees. Now, these tropical conditions consist of very important ocean temperatures above 27 degrees Celsius, high humidity. Okay, high humidity means lots of water vapor. Okay, warm conditions. And a friction-free surface. Okay, now, when do you think we experience this ocean temperatures above 27 degrees Celsius? Okay, when we experience tropical cyclones, okay, is usually late summer, early autumn. Okay, why? That's when the ocean temperature is the warmest. Okay, remember, when I explained to you in the previous hour, water takes much longer to warm up through the insulation. The water absorbs the insulation. But late summer, it releases this heat. Okay. Now, this is when the ocean temperature is the warmest. Okay. High humidity consists of a lot of water vapor. We have warm temperatures, so we have a natural flowing low pressure system that's developing. Okay. Now, if you look at it, right? Tropical storm Kenneth. Now, this is interesting. They're talking about the storm. So, what do we have when we look at the initial stage? Initial stage, it's when we have all those factors, the 27 degrees ocean temperatures. Okay, high humidity. Then we have the immature stage. Okay, this is a tropical storm. Okay, we don't give it a name yet. Immature stage is when the pressure is 1,000 hectopascal, millibar, right? We have wind speeds up to 80 kilometers per hour, right? And then we have a mature stage. Okay, that's when the pressure is below 1,000 hectopascal. And very importantly, we have a beautiful eye, the symbol. Perfectly shaped round isobars. Okay. Let me go back to a different diagram and show you how it moves. Okay. So let me clear out. I like the synoptic charts because I can do a lot of it. Okay. So first of all, when we look at tropical cyclones, pay attention. Mid-latitude cyclones is on the west. Tropical cyclones close to equator. Remember, that's the 50-degree latitude line. So this, it starts, initiate close to the equator, and it moves down the easterlies. Okay. Why? Because what's the wind belt over here? It's tropical easterlies. We have warm ocean temperature, as you can see, is over the Mozambican current, Indian Ocean. And then on a synoptic chart, this is what it will look like. You got a symbol. You got perfectly shaped round isobars, very close to one another. Okay? And we give it a name. And this name, it's Kenneth. Okay. Now that's a symbol, and very importantly, that pressure is well below 1,000 hectopascal. Okay. Now let's discuss this image that I've just drawn over here. First of all, the symbol is the eye. Okay. Calm conditions being experienced in the eye because the air is sinking. I'll explain, I'll draw a cross-section of a tropical cyclone in a couple of minutes. The system moves from west to east. Why? Because it's moving in the easterly wind belt. Okay. The isobars are very close to each other. Simple reason why is because of strong winds. There's massive convection updrafts that's being experienced. Cumulonimbus clouds that develops. Okay. Kenneth is the name of the cyclone. We named them according to the alphabet to be able to tell how many has taken place during the season. So in the name Kenneth, it means it's A, B, C, D, E, F, G, H, I, J, K. It means it's the 11th cyclone for the season. There was 10 previous cyclones. Okay. So it means the 11th one. Pay attention. The worst weather that's being experienced is in the southwestern quadrant. In this area over here. It's the southwestern quadrant. Why? Because the isobars are closer together to one another. Why? Because of the direction of the movement of the tropical cyclone. It moves in the southwestern direction, and because of the clockwise circulation of air that's being experienced. Okay. I forgot to mention, remember when we look at tropical cyclones. Now, that's what it looks like on the synoptic chart. I'm showing you a case study. They're talking about the tropical storm. Now, remember, grade 12s, pay attention to what I'm telling you now. They might give you a case study that says Hurricane Andrew. It's still a tropical cyclone, but it's not in the southern hemisphere. In which hemisphere is it going to be? It's going to be in the northern hemisphere because the Americas talks about hurricanes. When they talk about typhoons, we know it's going to be in the Pacific, right? Typhoons is also a tropical cyclone. A tropical cyclone, a hurricane, a typhoon, willy willies are all the same. We just named them differently according to different areas in the world. Okay, vitally important. They might throw you off. They might give you a case study about Hurricane Andrew, Hurricane Floyd, or whatever. It's still a tropical cyclone, right? Still, same amount of damage is going to be created. It forms the exact same way. Now, pay attention. Do you see any fronts? There's no fronts. Okay, there's no fronts whatsoever. You don't see cold fronts. You don't see warm fronts. Nada, nothing. Okay, make that clear. That's the biggest difference between mid-latitude cyclones and tropical cyclones. But boy, grade 12s, this storm is roughly 3 times smaller than mid-latitude cyclone. It's roughly 600 kilometers in diameters. But listen, look at those isobars. Look how close they are together. This is bloody nasty. You want to run. You don't want to be close to it, right? Because what does it do? We're talking about wind speeds up to 200 kilometers per hour. We experience storm surge when it makes landfall. Okay. Storm surge is when the cloud wavelength starts to increase. Okay, the waves becomes bigger. It starts bashing the coastlines, creating flooding. I mean, we look at, if a tropical cyclone arrives, we're looking between 400 and 1,000 millimeters of rain during the course of 2 days. Just to put it in perspective, Johannesburg, the whole year, experienced between 600 and 800 millimeters of rain a year. That's the amount of rain that Joburg experienced over a whole year during 2 days. So what are we going to experience? We're going to experience flooding. We're going to experience death. We're going to experience loss of infrastructure. We're going to experience loss of life, unemployment. We're going to experience diseases, especially afterwards, like cholera, because sewage and water get mixed in between, unhealthy living conditions. And especially developing countries are going to be very prone to this. Okay, so this is what it looks like on a synoptic chart. So the worst weather is being experienced over here. Pay attention to the symbol. Okay, now let's go back and see what they ask, just the case study. We look at the case study. You can see how the system moves, obviously. There's the equator probably, right? You can see it moves from east, you can see, to west. Moves in the easterly wind belt, tropical easterlies. There's making landfall. There's the symbol. You can see it. April the 24th, April the 25th. There you can see it's made landfall. Now let's just pay attention to what they've mentioned over here. Violent winds, landslides. You've learned about that in grade 10. Landslides happens, it's mass movement. Okay, we experience a hell of a lot of rain, mud, water, steep gradient. Gravity is the friend, not a friend when it comes to mudslides, right? So when you live close to slopes, it's extremely dangerous. Okay. As you can see, as the storm neared, schools were closed. Okay, flights were suspended. Now, as you can see, just a month before, we had Idai, right? That's before. Idai is what? If you look at it, A, B, C, D, E, F, G, H, I. That was the 9th for the season. Now we're sitting with Kenneth, that's the 11th. Okay. Now you can see 1,000 lives has been lost. Once again, grade 10, grade 12, think social, economical, environmental. This is a nasty bloody storm. Causes a hell of a lot of destruction. Now, especially when you look at a country like Mozambique. It's still a developing country. Most of the people live in rural settlements. Okay. They don't have access to decent infrastructure. Right? There you can see $2 billion in damage. Now, like I've mentioned, it's a tropical storm, right? It's a category 3, so eventually it would turn into a category 4, right? And it will be classified as a tropical cyclone. Okay, now as you can see, now remember, when it makes landfall, it dissipates. What does it mean? It dissipates. It dies out. Why? The simple reason why is because the water, the warm ocean water is the energy, is the fuel for this tropical cyclone. Now, first of all, when it makes landfall, it's going to experience friction. Secondly, it's going to experience, it loses its source of energy. And what's its source of energy? High humidity, water vapor, right? Warm ocean temperatures. So immediately it loses its energy. But once again, it still causes a hell of a lot of damage once it arrives because of the strong winds. Now, from a cross-sectional point of view, this is what a tropical cyclone looks like. Okay. You've got vortex 1, vortex 2. Okay, so obviously this is what cumulonimbus clouds. lots of rainfall. Why? Because we have very strong convection taking place because of the warm ocean temperatures. Okay, the air rising. Okay, but what happens up in the vortex? We experience divergence. The area situated over here is known as the eye wall. And because we have divergence taking place, we have sinking air. That's known as the eye. And it's calm, clear conditions. Okay, so that's a cross-sectional point of view of a tropical cyclone. Okay, eye wall, your eye, the calm, clear conditions. You got your vortex 1, your vortex 2. Okay, so that's our tropical cyclones. Remember, mid-latitude cyclones got fronts, the cold and the warm front. Okay, happens on the western coast of southern Africa. It moves west to east in the westerly wind belt. Tropical cyclones, tropical, hot, warm conditions. Okay, devastating. Not our friend. Give it different names. Okay, so big difference between the two of them.